All right, moving into 6.6, spending 1 day here. The author goes through a big development of where E comes from, that constant E that's on our calculator. E right here, which has the 2.718. It's just like pi, runs on forever and ever and ever, never repeats. Irrational. I don't think we need the whole development of it, but I'm just going to tell you where it comes from so you've seen it before. The definition of E. E is actually the limit as x approaches 0 of this function 1 plus x raised to the 1 over x. And it's also equal to the limit of another function as x approaches infinity of 1 plus 1 over x raised to the x. Okay, not that you need to know any of that, but that's where it came from. What you should be familiar with, though, is that E is the base of the natural log function. And I told you this the first day when we worked with logs. So a log base E has its own symbol, natural log. So log base E and natural log are identical. In calculus, we stick with the natural logs. And then the one thing you should remember, because you're going to need it when it comes up, you need to simplify it. If you ever see the natural log of E, know that that equals a value of 1. Because remember, it's asking, the base is E. E to what power equals E? Well, E to the first power equals E. So anytime you see natural log of E, simplify that to a 1. All right, that's the one thing you need to remember. What we're going to be doing in this section is taking the derivatives of log functions, but the only derivative rule we have is for the natural log. You look on your blue sheet. The only derivative that involves the log is of the natural log. That's the only one we have a rule for. So if we have something like a log base 10 or a log base 2, and we want to do derivative, we've got to convert it with that change of base property. And I gave you the change of base property, or I said log base A of anything equals, and I just switched it to log base 10 so that we could grab our calculators. I could have just as easily switched this to natural logs, which is what we're going to do in calculus. So instead of log base 10, we're going to switch to the natural log of x over the natural log of A. Then we'll be able to do derivative here because now we have a rule for natural logs. So that's the only thing we're doing today. I think it's the only thing we're doing today. I haven't turned the page yet. Is using our change of base property to rewrite and then do derivative there. So if we have something like log base B of something, we are going to switch that to the natural log of x over the natural log of b. Now, in order to work with this in terms of derivative, remember, natural log of b is going to be a number. It's a constant right here. This right here, that's a division, is a constant. So what I want to do is kind of pull it out in front and make it a multiplier. Times by the natural log of x. These are identical things. I just pulled this off of the top, wrote it to the side, left this 1 over. This is a constant right here. This is a constant multiplier that's going to carry along. So here we go. Find derivative. That's all we're doing. So we've got y equals, start easy, log base 2 of x. Okay, again, we don't have a rule for log base 2. We only have a rule for natural log. So we're going to use the change of base property to rewrite this. And instead of writing it as the stacked fraction here, log of x over, or excuse me, natural log of x over natural log of 2, I'm going to pull the constant out in front on the first step. So it's going to be 1 over natural log of 2 times natural log of x. Okay, now we're ready for derivative. So y prime, remember this right here is a constant. It's like a big number 2 sitting here. So you just carry it along. So don't think you have to do, there's only one x in the problem and it's on this one term here. This constant carries 1 over natural log of 2. The derivative of natural log of x is 1 over x. Derivative of x is a 1. Not that I need that. Okay, and then we just write the answer. So 1 over, you could write, because of the order it is, it looks like natural log of 2 times x. You can't leave it like that because then it looks like the natural log of 2x. If you want to leave it like this, you would have to put parentheses around the natural log of 2 so that that's one value and then times x. But what the author does is he flip-flops these two so that he doesn't need the parentheses. And now there's no confusion that there's two things down here. An x times the natural log of 2. An x times the natural log of 2. An x times the natural log of 2. So either of these two answers is acceptable. Without the parentheses, it's not acceptable. Okay, that's all we're doing today. Change a base, change it into natural logs because we have a rule for that. Number 2. Let's see, y equals log base 4 of sine x. So change of base, switch it out to natural log. So it's going to be the natural log of sine x over the natural log of 4. So I'm going to make it 1 over natural log of 4 times natural log of sine x. Again, this is a constant. It just carries along. There's no x on it. So y prime, here's my multiplier, 1 over natural log of 4 times, and now derivative here, derivative of natural log of sine x. Derivative of natural log of u is 1 over the u times by the derivative of the u. And what I see here, I see cosine over sine is going to give me a cotangent. The cotangent x times 1 over natural log of 4. So combined, that'll be cotangent x over natural log of 4. I kind of skipped a step in there where I put that cotangent up in the top. Hope I didn't lose anybody. Number 3, I need a new sheet. Number 3, let's go g of x equals 4 log base e of x to the 10th. Okay, first of all, hopefully you realize log base e is the natural log function. I don't have to do a change of base here. I'm just going to rewrite it with a natural log. Log base e is the natural log function. I can jump into derivative or I can bring this down as a multiplier before I get started using my log properties. So I've got 40 natural log of x. Now I'm ready for derivative. Derivative here, the 40 is a multiplier, just like before. Carry that along. Times derivative of natural log of x is 1 over x. So that's going to go over x. Okay, next one. Let's see, q of x equals log base 4 of x divided by log base 2 of x. Okay, I don't have a property that lets me simplify 2 logs divided. That's not on your sheet anywhere. So, and I can't jump into derivative yet because I've got logs of base 4 and base 2. I need the natural log function. So I have to use the change of base for the top and for the bottom. So the change of base here is 1 over, 1 over natural log of 4 times natural log of x divided by 1 over natural log of 2 times natural log of x. Okay, if you look here, you can see your natural log of x's are going to cancel each other out. Simplifying this, I've got a fraction divided by a fraction, 1 over natural log of 4 times by natural log of 2 over 1, natural log of 2 over natural log of 4. If I go to do derivative now, if I look over here, I don't even have an x term in here. This is a constant. Natural log of 2 divided by natural log of 4 is some constant value. I don't know what it is. If I can show you real quick. Natural log of 2 divided by natural log of 4 is a half. So I'm taking the derivative of a half. Well, that's 0. All right, number 5 says find and evaluate the derivative and compare with the end deriv. Find and evaluate the derivative and compare with end deriv. All right, so we've got y equals log base 3 of x, and we've got this at x equals 10. We want the derivative at x equals 10. Okay, so we'll go through the by hand way, and then we'll do the end deriv way. So first thing, I got to do derivative, so I need to do change of base. So that will be natural log of x over natural log of 3. So that's 1 over natural log of 3 times the natural log of x. Ready for derivative. Constant carries along. I've only got the one x term that I do the derivative of. This just carries along as a multiplier. Derivative here is 1 over x. So my derivative, if I flip-flop the order here so that I don't think these are 3 times x and the natural log of that, I get 1 over x natural log of 3. And now I can plug the 10 in, y prime at 10. So I get 1 over 10 times the natural log of 3. And then it wants me to evaluate that. So 1 divided by 10, 1 divided by 10 natural log of 3 is about 0.091024. Okay, end deriv, here's my equation. I'm going to go to end deriv, where we put in the equation. I'm going to stack it back up. Natural log of x over natural log of 3, comma x, comma evaluating at 10, when x is 10.